So today's lesson is on domain, range, and end behavior. We're going to learn how we determine each one of those. Our standard for mathematical practice today is precision. So these are math practice standards are standards that kind of go with every topic that we work on, but these are things we're going to kind of focus on today. And precision is making sure we have an accurate, efficient, exact, approximate. So these are symbols, definitions, and units correctly. So that was all over here. Today's lesson is a lot about notation. That's why we're using this practice standard. Probably I would make sure that you, we're just really looking at this accuracy piece right here today. So for this particular standard. All right, so as we're going through these lessons this year, you're probably going to want to grab the colored pencils out of the basket or out of the box on the table, or if you have your own. I don't think a highlighter is going to work very well with your textbooks because I think it's just going to bleed through. So you might want to make sure at the beginning of each lesson you've grabbed the colored pencils out and make sure they get back into their little boxes before the end of the period. You may want one or two colored pencils. You could use just a pen too as well if you want to bring a pen with you to class. All right, so instead of you writing out all the definitions, they're highlighted for you in the book, and it's probably something we want to actually kind of make an annotation on. So we're going to represent the interval on a number line. So an interval is part of a number line without any breaks. So probably I would underline that piece right there. A finite interval has two endpoints, which may or may not be included in the interval. So this would be something you maybe want to do this in a different color. So finite interval. Let's say I can change my color too. So a finite interval, two, which may or may not be included in the interval. And then an infinite interval is unbounded at one or both ends. So it says, suppose an interval consists of all real numbers greater than or equal to 1. You can use the inequality x greater than or equal to 1 to represent the interval. You can also use what we call set notation and interval notation that are shown in the table here. My next screen actually explains these two things a little bit more. So, so the first one they're showing here is finite. Okay, so let me see if I can go to the next slide and we talk a little bit about this. So set notation, the vertical bar means such that. So you read x, such that is the bar, x is greater than or equal to 1, as the set of real numbers x such that x is greater than or equal to 1. For interval notation, we do the following. Use a square bracket to indicate that an interval includes an endpoint, and a parentheses to indicate that an interval does not include an endpoint. So you might want to underline square bracket, interval includes endpoint, parentheses, interval doesn't include endpoint. For an interval that is unbounded at its positive end, use the symbol for positive infinity. For an interval that is unbounded at its negative end, use a symbol for negative infinity. Always use parentheses for positive or negative infinity. So you can write an interval where x is greater than or equal to 1 as a bracket because it's included, just like an underline means it says included, comma, and then the positive infinity to the parentheses. Now let's go back to that table now. So a finite, so it's a number, it's all real numbers from a to b, including a and b. So this is a finite interval. If it's including, we use the inequality signs. The set notation, you have the x such that x is between a and b. And then the interval notation, notice it uses the two brackets on the ends because a and b are included. All real numbers greater than a, so that's what this notation here is. And again, the set notation, it just puts that x bar in front of it with the curly Q brackets. And then because greater than a doesn't include a, they use a parentheses, and then it goes all the way to infinity, so we close it with a parentheses. All real numbers less than or equal to a. So again, you have the less than or equal to. The x bar with the less than or equal to in the curly Q brackets. And then it's starting at infinity. So the parentheses starts the infinity. And then it's less than or equal to. The equal to indicates that we've got a bracket instead of a parentheses. All right, so we're supposed to complete the table by writing the finite interval shown on each number line as an inequality. using set notation and using interval notation. So we're going to start with the inequality. So this first one, it looks like it's jammed between two numbers. So I would probably put my x in the middle. It's got closed dots, so we would use less than or equal to on either side to represent the closed dots, and then we throw our numbers in there, -3 to 2. Set notation, we know we use the curly Q brackets. I can't draw them either. X such that it's between -3 and 2. And then the interval notation, so since we've got closed dots, we would use the brackets. And we would say -3 to 2. So the big difference between this first one and the second one is we have an open circle right there. So that's going to change things a little bit. So I call this the sandwich notation. For our sandwich notation, that's going to be a less than, whereas the other one's going to be less than or equal to, because this is an open and that's a closed. So we're going to do -3 to 2. We've got the same x bar again. We're going to use the same notation we did on the first line. And then for the interval notation, we would use a parentheses to represent the open and a bracket to represent the closed circle. All right. So we've got to do this again, but this time it's not a sandwich one. It's actually got an unbounded end. So the first thing we would do is rewrite the inequality. Little shortcut on the inequality is notice where the arrow is pointing. That's the way the inequality sign should point, as long as your x is on the left. So x is less than or equal to this number right here, 2. And it'd be equal to because we've got the closed dot. The set notation is the x bar with the same inequality. And then the interval notation, because it's got an arrow, whenever it's got an arrow, that's an infinity. And because it's on the negative side, it's -infinity to 2, and the 2 would be a closed bracket because of the closed dot. All right, this inequality here, it looks like the inequality symbol, again, it's pointing to the right, but it wouldn't be closed this time because we've got an open dot, and then you keep that number right there too, so x is greater than 2. Set notation means I have the curly Q bracket, and x is greater than 2. And then I'm going to start with the 2, but it's a parentheses because it's an open circle. And it's going to go, not to 5, to infinity. And if you want to throw the positive on there, that's fine. So to positive infinity. All right, so we're going to reflect on what we've just done just a little bit, and these new books are going to do this throughout the lesson, so we kind of have some understanding of what's going on. We're going to consider the interval shown on the number line. Represent the interval using the interval notation. You'll notice it's arrows on both ends, right? So if we've got arrows on both ends, that means it's everything. So to put that in interval notation, this arrow means it's coming from -infinity, and that arrow means it's going to positive infinity. And we know with infinities, we use parentheses. And it wants us to ask, it is asking us what numbers are in this interval. Well, there's all the numbers are in this interval. So the way we write that is we say all real numbers. And then it asks us in number 2, what do the intervals bracket 0 to 5, bracket 0 to 5 parentheses, and 0, 5 with parentheses have in common, and what makes them different? Well, in common, they've all got the same numbers, right? So we would say all intervals contain the numbers between 0 to 5. All intervals, sorry, my handwriting is terrible, contain numbers 0 to 5. But it just depends on what's included and what's not. So we know that 0 to 5 includes both 0 and 5. 0 bracket to 5 includes 0 only. And then parentheses 0 to 5 includes neither. Neither 0 or 5. All right. This is an interesting symbol. It's the symbol, and it's a U. It's the union symbol, okay, of two sets. What do you think the notation negative infinity to 0 in union with 0 to positive infinity represents? Well, what we know is that this means, those parentheses mean that 0 is not included. So basically, this is the interval. If we were going to draw a picture of it, okay, so that goes from, and I'm going to draw my arrows over the top. It basically goes here, and it includes everything to the left of 0 and everything to the right of 0, but not 0 itself, because it says that 0 is not included according to the parentheses. So we would say that it includes all real numbers except 0. All right, so we're going to go through this explain one now. Identifying a function's domain, range, and end behavior from its graph. We call it the domain of the function. F is the set of input values. So that's something that you might want to maybe circle or underline. Domain is input values. Range is output values, or f of x, or really what we would say are the y values. End behavior of a function describes what happens to the f of x values as the x values either increase without bound or decrease without bound. So let's underline that. End behavior describes what happens to the f values or the y values. They increase without bound, so they approach positive infinity, or decrease without bound, which means approach negative infinity. For instance, consider the graph of the linear equation shown. From the graph, you can make the following observations. So, as the graph increases without bounds, so as the graph increases without bounds, so the x values go this way, we notice that the y values, because of the arrow on it, keep going up. So as the x values go to positive infinity, the y values go to positive infinity. As the x values decrease, so as the x values go this way, notice your y values are also going down. So as x decreases to negative infinity, f of x, or the y values, also decrease to negative infinity. All right, they did the work for us, but we're going to go ahead and try to understand what they did. Write the domain and range of the function as an inequality using set notation and interval notation. Also describe the end behavior of the function. So we're going to start with the domain, remember, which is the x values. So they gave us the graph f of x squared. So if we notice, for the domain, it has an arrow, so it's going in both directions. It goes on and on and on forever. So the way that we write that is for inequality, we say it goes from negative infinity to positive infinity. And again, infinities are always open. The set notation, we write the x and the bar with the same as the inequality. And interval notation, we'd say from negative infinity to infinity with parentheses. Now, the range is sometimes a little bit trickier because it's the y values. So you got to think about your y values. My y value started there. That y value is 0, meaning that y is greater than or equal to 0. Okay, and we have the equal to because it was a solid curve there, not dashed. The set notation is the same thing with the curly Q brackets and the y bar. The interval notation, we would start with a bracket because of the equal to, and starting at 0, and it doesn't end because it has arrows on the end, so it goes all the way to positive infinity. All right, the next part is the tricky part, so I'm going to change colors. Change? Yeah. All right, so this is talking about the end behavior. So as my x value is going to the right, as it's going positive or towards positive infinity, the arrow indicates that the y value is also going to positive infinity, or the f of x. You got to think of f of x as your y value on the graph, or change this to f of x on your graph, that label. As x goes to negative infinity, so I'm going to go to the left, the y value is still going up. So we can't assume it's always going to be negative and negative. It could be negative and positive. So we would say that the y value, or the f of x value, is going to positive infinity. All right, so now we've got to try to do this on our own, okay? Slightly different graph, okay? So if you want to try it on your own before I just say it, it's not a bad idea to pause the video and do that and try it on your own, okay? So the inequality, first of all, it has arrows in both directions, which means it goes on forever and ever and ever in both x directions. So we would say negative infinity to infinity. Set notation, again, you have the curly Q bracket and the x bar and negative infinity, to infinity in the curly Q bracket. Interval notation, it's infinity, so we use a parentheses for open, so negative infinity to positive infinity. The range, notice it never goes below that 0. So the range has got to start at 0, and range is going to be y values. So y is greater than or equal to 0. Actually, on this one, it's not equal to, is it? Nope, get rid of my equal to. Okay, so it's just greater than because it's not actually touching. It never touches. Sorry, I erased and I shouldn't have. It never actually touches that axis right there. Okay, it gets really close but doesn't touch. So set notation is the same as the inequality, except we put the y bar in the curly Q brackets. And then interval notation, it would start at 0, but it would be open, so parentheses, and it would end at infinity because of the arrow. And in parentheses, you can put a positive infinity in front if you'd like. The end behavior, okay, so let's see if we can get that down. Let me use a different color. So as my x's are going positive, where do the y's go to? They're also positive. So we'd say f of x approaches positive infinity. As my x values are going negative, so as my x values go towards the left, notice the y values come down and hit the 0. So the y values only approach 0, not infinity, because they stop right there. So f of x goes to 0. All right. So let's reflect on this a little bit. Why is the end behavior of a quadratic function different than the end behavior of a linear function? So let's go back and look at the quadratic and the linear. So the linear is that one, and notice your arrows are pointing in different directions. This is my hint. And the quadratic, notice the arrows are pointing in the same direction. So the book says there's a turning point, but you could kind of do either way. The end behavior of a quadratic function different from the end behavior of a linear function because a quadratic function's ends both point in the same direction, whereas a linear points in opposite directions. You could also say that the quadratic function has a turning point that changes the direction of the graph. So I'm going to say quadratic function points same direction for endpoints. Linear points opposite direction. Okay. In part B, the f values decrease as the x values decrease. So why can't you say that f of x approaches negative infinity as x approaches negative infinity? So let's go back and look at that on this one right here. So what they're saying is because these are coming towards the left, how come we can't see we're going all the way to negative infinity? Well, it stops at 0. The function never goes below that 0. That's why. So we would want to say that they don't decrease without bound there. Instead, they approach 0. So the f of x values have a bound at 0. At 0. All right. Right, the domain and range. Okay, so this one is one you're supposed to try on your own. We've done this a few times, so I'm just going to, if you want to try it on your own, go ahead and pause the video, or you can follow along with the video here. Write the domain and range of the functions, inequality, set notation, interval, describe the end behavior. So the domain, we've got arrows pointing in each direction, so domain would be from negative infinity to positive infinity, and it's going to be open. Set notation is the brackets with the x bar, and the same as the inequality notation. And then the interval notation, because there are infinities, we would go parentheses from negative infinity to positive infinity. The range is going to start here and go down. So we would want to say that y is less than or equal to 0, which means your set is y bar, y less than or equal to 0. And then the interval notation would start with including the 0 and going all the way to, oh, that does not right, is it? Sorry. It starts down here and goes up. So you would want to start with negative infinity and go to 0 and include it. You always, in interval notation, have to go from the most negative to the most positive. And then the end behavior, we've got that as x approaches positive, and so x is going this way, the y value is going down. So we would say that f of x approaches negative infinity. And as our x values are going to the left, we notice that the y values are going down again. So we would say f of x approaches negative infinity. Okay, so now we've got our second explain. This is kind of the second little thing we're going to talk about today. Graphing a linear function on a restricted domain. Unless otherwise stated, a function is assumed to have a domain consisting of all real numbers for which the function is defined. Many functions, such as linear, quadratic, and exponential functions, are defined all real numbers, so their domain, when written on the interval notation, is this. So if we have all real numbers, you write the domain like that, or you can write all real numbers, or you can write this, which to write it in your own handwriting is just that, an R with a bar through it. Sometimes a function may have a restricted domain. If the rule for a function is restricted, if a rule for a function and its restricted domain are given, you can draw a graph and then identify its range. So they give us kind of an example that they filled in for us here. They gave us a line. So remember, when we're graphing a line, you can graph the y-intercept first and then count the slope. So they graphed the y-intercept and they counted up 3 and over 4. The other thing you can do is, since they gave us a domain, is we could put our endpoints in. So if we put our endpoint into that, I'll do one of them. 4 plus 2, 4 cancel, I'm left with -1. 3 times -1 is -3, plus 2 is -1. So that's where they got that value from, okay? And we could do the same thing for the other one, and then we would get out a 5. So the endpoints are included in this graph. To get the range values, they put the domain values in, and then the range values popped out. So that's where they get the -1 and the 5 from. All right, so let's try this again, a little bit different on this one. It says, since f of x equals -x minus 2, this is the domain, meaning all my values have to be bigger than -3, okay? So I'm going to actually go ahead and calculate the -3 and figure out what that value is. Remember, that's function notation, and it means I'm taking the -3 and I'm plugging it into that function. So f of -3 equals -3 minus 2. Double negative goes positive. Positive 3 minus 2 is 1. So we would say that the point is -3, 1. The endpoint that they're looking at here, we don't really know the endpoint because it is not included in the graph. Oops, sorry, is not included in the graph. And they want us, since it started in set notation, they want us to write the range in set notation as well. So our range would be y bar, y, and I have to figure that out a little bit. Okay, so let's try drawing our graph to help us figure out what the range value is. So I know I've got this point, -3, 1 on the graph. So I'm going to go out -3 and up 1. I know it is a greater than or equal to, so I'm going to go an open circle. Maybe if it'll let me draw. So an open circle, not a closed circle. And then I'm going to go ahead and just count this slope. It's down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1. Sorry, it's not letting me draw very well. It's going to look like that. So if I think about the y values, the range, it starts here at that y value, which is 1. And it goes everything less than that, right? So y is less than 1. And here's that 1 that popped out again. All right, so let's reflect on this a little bit. In part A, how does the graph change if the domain is -4 to 4 instead of -4 to 4? So notice they have the parentheses versus the brackets. So basically that means that the endpoints are no longer included, or the graph no longer includes the endpoints of the segment. So graph no longer includes endpoints. In part B, what is the end behavior as x increases without bound? Why can't you talk about the end behavior as x decreases without bound? So what's the end behavior as x increases without bound? So as we increase without bound, the end behavior, so as my x value goes this way, the y value is going down. So we know that the y value is getting negative. So we could write that as x approaches infinity or positive infinity, f of x approaches negative infinity. Why can't you talk about the end behavior as x decreases without bound? Well, there's nowhere in the domain where the x is actually decreasing without bound because it has an endpoint. So domain doesn't include x values less than -3. So cannot decrease without bound. Okay. All right, let's look at this number 9, your turn. So we're supposed to, for the given function and domain, draw the graph, identify the range using the same notation as the given domain. So all we have to do is find the range. So again, I could graph that, or I could plug in my endpoints and then connect the dots, basically. Notice that one's a bracket, and then that one's an open circle. Or that one's a closed circle, that one's an open circle. So if I put in the -6, so f of -6 equals -1/2 times -6 plus 2. 2 goes into 6, -3 times. -1 times -3 is 3. 3 plus 2 is 5. So -6, +5, and it's going to be a closed circle. Okay, now I'm going to do the 2. So f, so I'm basically plugging in those endpoints. F of 2 equals -1/2 times 2. 2's cancel. So I've got -1 plus 2, which is 1. So I've got the point out 2, up 1, and this time it's an open circle. I'm going to go ahead and connect those. So my range would be this y value here, which is 5. Use R for range. Which was closed. Oh, but I have to use that notation, not interval notation. So I have to use -5 less than or equal to x, and because that's an open circle, less than, I'm sorry, I messed this up. Let me try that again. We'll just get rid of all of that there. Okay. Don't listen to me this time. We're going to get it right. Okay. So my smallest y value is actually here. So I'd actually want to start with the 1. The 1 is, it's an open circle, so it's not included, so it's just a less than x. And then it goes all the way up to that 5, so it ends here at this y value, but that one is included, so it gets an equal to sign. All right. For the given function domain, so we're doing the same thing. This time they say the domain goes from -infinity to 3, so I'd probably put that 3 in, and then maybe graph the line like I know I do with y equals mx plus b. So f of 3 equals 2/3 times 3 minus 1. My 3's are going to cancel. I've got 2 minus 1, which is 1. So I have the point out 3, up 1, and it's going to be closed because it used a closed bracket there. So it's going to be a closed dot if it will let me draw it, which it's not. All right, we're going to pretend that that's a closed dot. And then I'm going to count this slope. So I'm going to go out or down to over 3. The problem is that it's going in the wrong direction. I need actually to go in the other direction. So I'm going to go, and it wasn't down 2, it was up 2 over 3. So I'm going to actually go down 2 and over 3 to the left, which would be here. So that's actually the arrow that we want with a closed circle there. So my range is going to be my smallest y value is going to be negative infinity. And my biggest y value is going to be this y value right here. Let me draw, which is a 1. And that's going to be closed. All right, there's one last little piece to this, okay? So bear with me. I know it's getting long. We're modeling with a linear function. We're going to recall that when a real-world situation involves a constant rate of change, a linear function is a reasonable model for the situation. The situation may require restricting the domain's function. So we're supposed to write a function that models the given situation. Determine a domain from the situation, graph the function using the domain, and identify the range. Joyce jogs at a rate of 1 mile every 10 minutes for a total of 40 minutes. Use inequalities for the domain and range of the function. Okay, so where they're getting this from, they're saying that her rate is this. Basically what they're doing is they're taking the 1 and dividing by 10. Okay, and that gets us the 0.1. And notice it goes miles per minute. So we use those labels right there. Her jogging distance, D, they're going to use that D in this whole, all of these type of problems. In miles at any time in minutes is modeled by this. They took that 0.1 and they multiplied it by the time for the function. Since she jogs for 40 minutes, the domain is restricted to the interval 0 to 40. So that was just coming for how many minutes she is jogging. And then there's the picture of it right there. All right, so a candle burns, or it's a candle 6 inches high burns at a rate of 1 inch for every 2 hours. So, the right problem here. So they're talking about, and it says even gives you a clue here, inches per hour. So we would want to do 1 divided by 2, which is the same as 0.5. Use interval notation for the domain and range. Okay. So the candle's height in inches at any time in t hours is modeled by h of t, and then we learned that we just take the 0.5 and put a t after it. That gets us the function. Okay. Oh, there's a catch on this one. This one says it starts here, so that's an initial value. So actually we do 6 plus 0.5t. So it's actually starting at 6 and decreasing. The last one started at 0 and increased. So since the candle burns for 5 hours to the interval, well, it stops at 5, so it's got to be 0 to 5. The range is, so this is where we have to come up with the y values. So you probably want to plug it into that function right there. So if I start at 0, and I plug a 0 into that, 6 plus 0.5 times 0, that's going to cross out. I'm just going to have 6. So I know that probably my highest value on the graph is 6. Okay, I'm going to put that at the end. And then I'm going to do 6 plus 0.5 is the same as 1/2. So, and then my end time is 5. Well, that's not so pretty. Let's see, if we do the 6 in halves, that's 6 times 2 is 12 halves plus 5 halves. I think I have a sign mistake. That's supposed to be minus. This is supposed to be a minus sign. Sorry about that. That's minus, 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 minus. Okay, so now that we've got the sign fixed. So 12 halves minus 5 halves is 7 halves, or 3 1/2. So you could either list 7 halves or 3.5 here. Either way works. They did 3.5, and we would have closed brackets on those because the domain was closed. All right, so all I got to do is graph those points. Okay, the 0 is going to go with the 6 we said. So that's a closed dot up here. And then the 5 is going to go with the 3.5, so it's going to be something right there. And then your closed dots. Sorry, get the dots to connect. All right, so let's reflect on that just a little bit. Okay. So in part A, suppose Joyce jogs for only 30 minutes. How does that change the domain? Well, Joyce was jogging for 40. It would change the domain to 0 to 30. Okay. How does the graph change? So the graph would change. Let's go back and look at that graph really quick. Oops, Joyce. So since this was the function right here, we would put in a 30 right there. So 0.1 times 30 would be 3. So that would mean that the graph would end at, the right endpoint would be at 33 instead of 30 or 44. So the graph changes because the right endpoint is going to be at 33. How does the range change? So the range would come down, since we changed that point from a 4 to a 3, the range would come down to a 3. So the range is going to be from 0, and they used a D in that problem, to 3 for distance. All right, last little bit is your turn, okay? So while standing on a moving walkway at an airport, you were carried 25 feet every 15 seconds. So there's feet per second. So you would do 25 divided by 15, which reduces to 5/3, right? Feet per second. For 1 minute. Write a function that models the situation. So the function would be f of, let's see, what did they, oh, they use d of t. So the distance for the time traveled, and those variables are in our graph already, be negative 5/3 t. Determine the domain for the from the situation, graph the function, identify the range, use set notation for the domain and the range. So set notation. So let's see if I could graph this. Actually, I know it's going to start at 0. I don't know where my negative got in there. I think that's a typo. I think I just had my pen drag here. Okay, so 5/3. So we're starting at 0. And it says that we're going to times. Oh, notice they did something tricky here. They say your time is in seconds, whereas this time was in minutes. So we're going to talk about 60 seconds. So 5 times 5/3 times 60. 3 goes into 60 20 times. So 5 times 20 is 100 on the graph. So it would be here. And that would be our picture of our graph. So the domain, we've got the graph of the function. The domain is going to be from 0 to 60. So domain, I like to use a D, and it said to use set notation. So x is between 0 less than or equal to x less than or equal to 60. Oops, curly cues. And then the range, we're going to use set notation again, y. It starts down here at 0, less than or equal to, less than or equal to, and it goes all the way till we hit that 100 curly cue bracket. All right, so the last thing you have to do to get your points for the day on the lesson is you have to fill out the elaborate section, and you're going to do that on your own. It's a reflection of the lesson. I'm going to give you some hints on this first one here. I want you to actually, it says write 4 intervals, okay? So the 4 intervals you should be writing about are bracket A to B, bracket A, B parentheses, so you're going to write the meaning of these, A parentheses, B bracket, and then A parentheses, B parentheses. All right, so you're going to understand, you need to describe what each one of those is like. You're going to do that on your own. You're going to answer question 14, what impact does restricting the domain of a linear function have on the graph of the function? And then you're going to do your essential question check-in. How does the slope determine the end behavior of a linear function with an unrestricted domain? Once you've done that, you can get your class points for the day. All right.